So we need to start some carboxylic acid notes. This video is going to be kind of an overview of carboxylic acids in general. We're going to talk about naming not just the carboxylic acids themselves, but also their carboxylate anions. But we're also going to make some big overall connections in terms of, if you've been following along, you know that we're learning this organic for a reason. We're supposed to be able to use this information to understand biochemical processes that are happening inside of your body. Right? So we're actually going to look back on possibly some things we learned in biology and see if we can understand those things a little bit better now that we have some of this prior knowledge. So just bear with me. I'll try not to make it too in-depth, but I do want you to understand how this connects to things in your future. Right? If you're going to continue with chemistry and you're going to need to know some of this stuff, it's important that you can make these connections. So first off, these carboxylic acids, they contain a carboxyl group, right? So I have here a carbonyl group technically, right? The only thing you need to create a carboxyl group is to oxidize that carbonyl group, that aldehyde, and put a hydroxyl group on it, right? So a carboxyl group still contains a carbonyl carbon like we talked about before, that carbon that's double bonded to an oxygen. It just also has another oxygen connected to it. So that's what you're looking for. That's what a carboxylic acid has, right? Otherwise, carboxylic acids are called acids for a reason. We're going to talk about how they have acid-like properties, how they can donate protons to a solution. So that hydrogen that's attached to this hydroxyl group is actually very loosely associated with that oxygen and can be lost very easily, right? Leaving behind what we call a carboxylate anion, which would be that same thing we were talking about, that carboxyl group without the hydrogen. And you have a negative associated with that oxygen that was attached to a hydrogen, because the hydrogen is positive, that oxygen is going to end up negative, right? Lots of different things that we're going to be going over. So again, that's not clear right now. That's okay. I'm going to do a lot of examples and you'll probably pick up on it as we go. So naming carboxylic acids, right? Two different systems as always. There's the IUPAC system. There's common names that you can use. But we're going to start with IUPAC here. So if you look at the examples at the bottom of the screen, right? If I have 1, 2, 3 carbons in this example, I'm still going to use my same prefix as always. I'm going to call it a propane. I'm just going to drop the E and I'm going to throw an oic acid at the end. And now it's a carboxylic acid. So naming for these carboxylic acids is similar to aldehydes and ketones. Just drop the E at the end, add a new ending. For aldehydes, it was Al. For ketones, it was ONE. For carboxylic acids, it's this oic acid that you need to add. Otherwise, it's fairly simple. This one over here with 1, 2, 3, 4 carbons would just be called a butanoic acid. It was a butane. I dropped the E and add oic acid to the end. You also could have aromatic versions, right? Like this one above. It would be called benzoic acid. So when you see that, you should know what to call it, right? It's what you get when you oxidize that benzaldehyde we talked about. So now it's just called benzoic acid. You can add substituents to any of these things, which follows normal rules, right? Just remember that if I was to add a substituent to this benzoic acid, let's say I was going to put a hydroxyl group here off of that ring, as well as my carboxyl group over here, right? This would just be called now maybe a 3, maybe an O hydroxy benzoic acid. So it should be pretty easy to pick up on because it's very similar to all the things we've done before. I know that each individual thing that we learn really isn't all that hard. It's just becoming harder and harder to keep all those things differentiated from each other because we have so many things that we know how to name now. And it's just going to get harder. So just keep working at it and keep trying to figure out these things. Do a lot of practice and we'll be good. Common names, on the other hand, right? It depends. You're supposed to use the same root words that we use for aldehydes. So for these first two examples here, this 1 carbon compound would have a form prefix, right? We learned those in the aldehyde videos. This 2 carbon compound here would have an acid prefix, right? But instead of calling it formaldehyde, right, I'm going to call this a formic acid. Instead of calling it acetaldehyde, I'm going to call it acetic acid. So just change the ending, use the same prefixes we talked about in aldehydes, and it should be pretty easy. Right? We only talked about 4 prefixes: form, acid, propione, and butyr. So I have all of those examples on this slide. So up here is another formic acid. It's just the drawn out version of it. This one's an acetic acid, which is something that should sound familiar to you guys. You should know what that is, actually, because it's the main component in a very common substance. That's the active ingredient. That's the actual molecule that makes vinegar what it is, right? And again, we talked about this already, or at least I talked about it on the first slide. This is an acid for a reason. I can remove this hydrogen, and all of a sudden it turns into something that I also know how to name from before. This is called this is called an acetate anion, right? So that's something that you should recognize, right? It's related to this acetic acid. It's something we memorized before. We just looked at it differently. Because again, there's 2 carbons in there. There's 3 hydrogens. And there's 2 oxygens. And it's got a -1 charge overall. Acetate should be extremely familiar to you. You memorized that a long time ago. Right? So that's what happens when you remove that hydrogen from acetic acid. It becomes that acetate conjugate anion. So there was a reason why we memorized that before. It would just make it that much easier now for you to know what it is. Otherwise, if I removed a hydrogen from formic acid, it would turn into what we call a formate ion, right? We're going to learn how to name those ions. There's rules to that follow a pattern, if you haven't noticed it already. Down below, these two with common names, this is not a propanoic acid anymore. I'd call it a propionic acid, which is really, really similar. It's like I just moved the O. But if I call this a propionic acid, or if I call this one over here a butyr, excuse me, I put the Y early, a butyric acid, I have to be careful when I do that because that actually changes things slightly. So if I go backwards to that slide before, I have those same 2 examples, propanoic acid, butanoic acid. But if I have the IUPAC names and say I added a branch onto these things, say I added a hydroxyl group right here to this propanoic acid, right? My old rules would tell me to just say, oh, 2-hydroxy in front, propanoic acid, and that's correct here. If I was to add a methyl to this butanoic acid on this carbon here, I'd call it a 3-methyl, butanoic acid. The difference being, if I say propionic acid or if I say butyric acid, I can't use numbers. I have to use Greek letters, which is kind of confusing. So I'm looking right here because it says 2, 3, 4, 5 or alpha, beta, gamma, delta. What that means is essentially when I'm looking at a carboxylic acid, there's a number 1 carbon right here that's always assumed to be the 1. I don't have to put a 1 in front of the IUPAC names because of that, just like the aldehydes. But understand that I can't fit anything new onto this 1 carbon. It's just not possible to put anything new on this 1 carbon because it's already got 4 bonds, right? So I can't have a substituent on number 1. So although you would usually think of alpha or A being the first letter of the alphabet, what it means in this case is it's the first option for a place you can put things, right? So technically, the 1 doesn't have a label. The 2 is my alpha, So if I put that hydroxyl group here like I did before, I can't say 2-hydroxypropionic acid. I have to say alpha hydroxypropionic acid. So again, that makes things a little bit more complicated than you probably want them to be. So I don't usually use the propionic acid name. I call it propanoic acid instead, because then I can say 2-hydroxy. But you have to understand how it works, right? 2 is alpha because it's the first spot you could put something. 3, where I had that methyl group, is a beta. So this would be a beta methyl butyric acid, right? Again, if I had a chain long enough, right, I could have up to 4 options possibly, but we're actually never going to make one this long because you don't even know a prefix for a common name that's 5 carbons long. We only went up to butyr. So really we just need the alpha, the beta, and the gamma positions, but obviously I could keep going further. I could have a delta and just keep going on down the Greek alphabet, which is kind of similar to ours, but not exactly, because gamma is not the same thing as a C. So again, just work with this alpha, beta, and gamma. That's the most you would possibly need. Right? You don't even have to worry about the delta, but understand it would be 2, 3, 4, 5, right? Alpha, beta, gamma, delta would be 2, 3, 4, 5. And also see how I drew those things, right? It doesn't have to look like these type fonts look. Alpha is just a fish, right? Beta is a bee with a longer tail. Gamma is a fish pointed down. And delta just looks like a music note, kind of. So it's a lowercase d, it's just got a tail on it, right? So you don't have to make those perfect. I should be able to tell what they are. But again, if you're trying to type in a form, I don't know how to make a beta in Google Forms, so I'm probably never going to call something beta methyl butyric acid in one of those cases. I just call it a 3-methyl butanoic acid. So again, that's the one tricky thing with the common names. If you use common names, you have to use alpha, beta, gamma, delta for substituents. So don't use common names for those if you don't want to do that. All right, so that seems like a good place to start or to break up these notes.